Hi, today we continue to talk about Foundation Fieldbus. Today we discover calibration. Let's start. Calibration. What's mean calibration? Calibration is the correction of sensor reading and physical outputs. So the match a standard calibration and the range is different concept. This is a concept, is a serious concept. Actually, calibration just is a sensor, it's the physical signal should match the electrostatic signal. That's it. Okay, is for analog transmitter. Calibration and range setting were performed using the same set of potentiometer. Hard communication uses the 4 to 20 mA signal. The loop current can be calibrated. See, hard just calibrate loop current. Okay, but in Foundation Fieldbus there is no current signal. So if you use hard communication 4 to 20 m system, the range, if you set the range, should the transmitter and the controller. Okay, if you set the transmitter in the range of, also if you set the controller in the controller for soft logics IS logics 5 control logics is AI model, analog input model, you should set is calibration. Okay, FF transmitter don't have 4 to 20 mA output. The range is set in the controller, just about the function block. It's the same thing as the Profibus. This smart pressure transmitter, hard communication transmitter. Okay, this one trim adjustment, range adjustment. These all the transmitters they have 3 blocks. Is ADC, is microprocessor, is DAC. Okay, if you trim the sensor here, if you trim here is output. Okay, then if you range in here. This is the Foundation Fieldbus pressure transmitter. They have AI block and transducing block, and if you do some calibration, your trim just in here is low, car point low, car point high. If you range, just in AI block. Okay, transduce scale, out scale. This one is all the information just in the transducer block, the AI block. Okay, transducing from here is, for example, minus 15 millivoltage to positive 15 millivoltage. Is if your calibration is 0 to 100 feed well. Okay, this go to is the output. Okay, calibration is called trim. When you are setting the transducer block along with the engineer unit to make the output of the transducer block a digital value, scaled in real units of measurement. Calibration transmitter step procedure. First, the transducer block, you should put this one, you should put out of service. Okay, OOC mode, use handheld FF communicate, or in the host system in the DCS control room you can set up is out of service. Okay, then a standard flow pressure, if you is applied to the transmitter sensor. Okay, the the core point law parameter is set to equal this applied pressure. A great pressure is applied to the sensor, then you set the core point high parameter is equal this pressure. Okay, then set all the information since data, since core, somebody who do this job. Okay, after that you should return to all the system, return to auto. That's it. This is the calibration transmitter. If you do range transmitter, you should go to the AI function block, XD scale and auto scale parameter. Okay, then here have three kinds: direct, indirect, indirect square root. Direct means if your input senses some information, for example, is level is from 0 to 2, but if your output still this one, 0, 0, is the same thing, just meter. You don't need mathematics, use direct. But most time we use indirect. Is direct, the AI block will publish the signal output by the XD block. Regard, This is indirect. The AI block will mathematically scale the signal from the XD block into a range specified by auto scale parameter using a linear equation. The indirect square root, this one just a flow transmit, different pressure flow transmit, use the indirect square root. Okay, we should set up all this one. Okay, this is the example. Is, for example, is tank pressure transmit, hydrostatic pressure. Hydrostatic pressure is 3.4 to 4 psi. Therefore, here 100% is 14.12 psi. How to got this number? In the future we talk about calibration. We talk this one how to calculate this one. Okay. This one is in the AO block parameter. We just often use the L type. You should indirect. Is XD scale is here to here. Okay. Auto scale is 0 to 40. 0 to 40. Okay. If your auto scale still PSI, here is direct. Okay. But most time is indirect. Okay. This one is flow transmitter, different pressure flow transmitter. It's an indirect square root. This flow formulation is Q is flow equal K is constant. Square root delta P is a different pressure transmit. This pressure minus this pressure equal delta P. Okay. This one XD L type indirect square root. XD scale here from 0 to 125 inch watt is out scale is 0 GPM. This flow. Okay. Set the XD scale parameter to the physical range of measurement directly sensed by the transducer. Set the out scale parameter to the corresponding range of measurement the transmitter to report to the rest of the control system. Set L type to indirect to enable this translation from one range to another. Set L type to direct if the raw transducer range is appropriate to output to the rest of the control system. For example, If the transmitter directly sends a flow pressure and we wish this very same pressure value to be published onto the Fieldbus network, with no scaling, we use direct. Okay. This example, Emerson pressure transmitter 3051 with Foundation Fieldbus. It's mark this one. It's important, yeah. It's zero trim. Before we talk about the follow transmitter or follow calibration and the range. Yeah, this calibration transmitter, range transmitter, but we don't talk the zero trim. Actually, zero trim is very important. Zero trim transmitter are shipping fully calibrated up per request or by the factory default of all the scale. Okay, zero trim transmitter in the side you can zero trim. How to zero trim? First, close this wall, then open this wall, then this upstream side pressure equal downstream side pressure. After that, close this wall. Okay, this pressure here pressure equals here pressure. Then you can do the trim. You can use two kind to use guide setup is like this: select zero trim, exact zero trim, or use manual setup. In the Delta V DCS system, you can set up everything. Before you set up, you should do this job in the side. Okay, or if you don't know how to do, you can disconnect here, make sure two sides is open to the atmosphere. It's the same pressure. 14.7 is the PSI atmosphere. Okay. Is a zero trim is a single point adjustment used for compensation mounting position under land pressure effect. When performing zero trim, ensure the equalizing value is open and all wet leg are filled to the correct level. Okay. Here equalizing wall here, equalizing walls here. Here should close, here should open. So this side and this side should be equal pressure. Okay. Calibration is typically carried out on workbench. If you for the calibration, you can't do in the side. You have to go to the disconnect is the transmitter, go to the site, the workbench. But if you are in the site, the source pump is not standable, so it's not possible to calibration Fieldbus transmitter use only a configuration or configuration software. Okay. Next, we talk the troubleshooting. Troubleshooting. It just first is a cable resistant. You should measure resistor how much. Before you measure resistor is between positive contactor and shared, negative contactor and shared. You should be disconnect. Is shared at the end at the point. We are to test the shared at the point should be disconnected. Okay, signal strength. The Fieldbus Foundation is signal is peak to peak signal voltage. Is normal is 350 millivoltage and to 700 millivoltage. If you're beyond this one, you have some trouble. If you know this one, you still have some. Okay. If you use the straight peak to peak, signal voltage. You can use the oscilloscope in the side to measure. It's a portable oscilloscope. You can measure what's going on. Okay, that's it. This is all the calibration. It's foundation feedback. Actually, we often do just zero trim. Yeah, if your zero trim important, if something wrong, you first do zero trim. How to do zero trim? Just here. Okay. So all these foundation feedback information. Thank you very much. Okay.